Hi, I'm Carlos Dominguez. In this video, I will tell you how to get started optimizing your games with Intel Graphics Performance Analyzers. Intel GPA is a treasure trove of tools aimed at improving your performance profiling workflow, ranging from beginner-friendly bottleneck detection and automated hotspot features in our Frame Analyzer tool to complex CPU-GPU profiling in Graphics Trace Analyzer. I would like to highlight some of these workflows and how they can help you optimize your games today. Arguably, the largest change in GPA in recent history has been the addition of stream capturing in Frame Analyzer. Adding to our single frame capture capability, this new feature allows developers to capture a stream of as many frames as wanted throughout the lifetime of the game. This capability is particularly exciting for us, as it allows developers to analyze problems that were virtually impossible to debug in single frame capture mode. Some examples include intermittent glitches, random hitches, and issues with multi-frame algorithms. In order to navigate these new streams, we've introduced a multi-frame view within Frame Analyzer. This view allows developers to navigate through the captured streams and quickly identify problematic frames by analyzing frame times, metric data, and capture screenshots. Additionally, developers can iterate through multiple frames without having to recapture their games. Once you have selected your frame of interest, there's a few basic questions we'll need to answer. What are my most expensive draw calls? What are they drawing? Where in the graphics pipeline is the bottleneck? Identifying the most expensive draw calls in Frame Analyzer is as simple as scaling the bar graph by GPU duration. This will accentuate draw calls and other GPU events with long durations. Selecting a draw call on the bar graph will populate the resources view with all resources corresponding to this draw call. This includes bound textures and buffers, shaders, pipeline state, geometry used, and render targets. This information allows us to understand what this draw call is drawing. To properly identify where in the graphics pipeline the current draw call is bottlenecked, we will leverage GPA's automated hotspot analysis. By clicking on the 3D Pipeline tab on Frame Analyzer, you can view a diagram of the graphics pipeline, color-coded by bottleneck distribution. Red color in any node will identify it as the bottlenecking stage. Clicking on this node will display additional information such as the metrics used to infer this conclusion. It also provides a brief explanation of the potential bottleneck and mitigation strategy to alleviate this issue. For more information on these bottleneck types, please refer to the various Intel performance optimization guides on the Intel Developer Zone in the links. I'm also excited to announce that the backend supporting our new stream analysis is now accessible to all developers. Our new Intel GPA Framework allows developers to access our C++ and Python programmatic interfaces to create tools for their specific needs and use cases. Some examples are integration into game engines, automated profiling, and performance reporting in continuous integration pipelines, to name a few. Our Graphics Trace Analyzer tool has been redesigned from the ground up. With an improved collection mechanism and new quality of life features, Trace Analyzer has become a powerful tool to gain a holistic view of your game's runtime and its impact on the system. It is great at identifying if your game is CPU or GPU bound. Additionally, some popular game engines are already instrumented with events that can be visualized in Graphics Trace Analyzer. Custom instrumentation can also be achieved by using ETW or ITT events. We barely scratched the surface of what Intel GPA has to offer, so I encourage you to visit software.intel.com/GPA and download our latest release to start optimizing your games today. Thank you for watching.